My dear students, welcome to my channel Physics by NKR. In the last video, we discussed about vector addition methods. The first method we discussed was geometric method using triangle law of addition and polygon law of addition. And the second method is numerical method using parallelogram law of addition. And we derived the resultant of two vectors using parallelogram law as a bar plus b bar modulus is equal to under root a square plus b square plus 2ab cos theta. And the direction made by the resultant with the vector a bar is alpha, and tan alpha is given by b sin theta by a plus b cos theta. Suppose if the modulus of the two vectors are equal, that means a is equal to b, then this big formula reduces a short formula, that is modulus of a bar plus b bar is equal to 2a cos theta by 2. And the two angles alpha and beta made by the resultant with a and b are also equal, which is equal to theta by 2. And not only that, this parallelogram also verifies commutative law of addition. That means if we add a bar with b bar, you are getting a bar plus b bar as the diagonal. And in the parallelogram, the opposite sides are equal. That's why this vector is b bar and this is a bar. That means you are again adding b bar with a bar, getting the same diagonal a bar plus b bar. That means a bar plus b bar is nothing but b bar plus a bar, which is commutative law of addition. So we can use these laws in solving some problems. I am giving very few examples and you can extend it to any number of problems. For example, the rule of addition is modulus of a bar plus b bar is less than or equal to a plus b. This is the rule of addition. That means if a is equal to 7, b is equal to 3, then the maximum value of modulus of a bar plus b bar is a plus b, which is 7 plus 3 is 10. And the minimum value of the addition, modulus of a bar plus b bar minimum, is a minus b, that is 7 minus 3 is equal to 4. And this happens when theta is 0 and the minimum value comes when theta is 180. That means as the angle between the vectors increases, the magnitude of the resultant decreases and becomes minimum when the angle is 180 degree. So basing on that, if modulus of a bar plus b bar cannot be greater than a plus b and cannot be less than a minus b, that means the values must lie between 10 and 4 only. So next, numerical example. If the maximum minimum resultants of two vectors a bar and b bar are 16 and 4, then what are the values of a and b? Here, a plus b is 16, a minus b is 4. By adding these two equations, we get 2a is equal to 20, a is equal to 10, and automatically b is equal to 6. This is very simple example. And the next one is the resultant of two forces, 1 Newton and F Newton, is 1 Newton and perpendicular to 1 Newton. This is statement wise problem and you have to solve it geometrically. Here I am constructing a parallelogram. This 1 Newton force is represented along x-axis. Because the resultant is normal to 1 Newton force, the angle between the two forces 1 Newton and F must be greater than 90. That is one guessing. Now, this is the resultant which is normal to 1 Newton. I am constructing this parallelogram. because opposite sides are equal. This is 1 Newton and the opposite side is 1 Newton. And this is the resultant. And this is the F. Now you consider this right angle triangle. Alpha is 90, it is given because the resultant is perpendicular to 1 Newton. So beta is to be found. For that, the value of opposite side is 1 Newton and adjacent side is also 1 Newton. Then tan beta becomes 1 by 1. Then beta is equal to 45 degree because tan value is 1, angle is 45. When beta is 45, the angle between 1 Newton and F Newton is definitely 90 plus 45, that is 135. Of course. Then sin beta is equal to opposite side by hypotenuse. Hypotenuse is F, opposite side is 1 Newton. Then sin beta is equal to 1 by F. But beta is equal to 45, whose value is 1 by root 2. Then the value of F is root 2 Newton. So, here we are not using the big formula, but by geometric method, this problem is solved. So, we can use the formula or by geometric method, we can solve some problems. The next example. These are the examples based on geometric method of addition. And moreover, polygon law of addition. As you know, for the addition of two vectors, we have to use a triangle of addition because two sides of the triangle represent two vectors in one order and their resultant is represented by the third side in the opposite order. Suppose if you want to add n minus 1 vectors, you have to consider a polygon of n sides because to accommodate the resultant, one more side is required. The vectors are n minus 1 and the resultant is 1, total is n vectors. So, we have to consider the polygon of n sides. Okay. Now, let us consider this problem. Three forces, each 10 Newton, act on a particle simultaneously. Then, each force makes an angle 90 degree with the next one. The resultant is, this is the problem. So, the n minus 1 number is 3. Then what is the value of n? 4. So, we have to consider a quadrilateral. Because each force is 10 Newton, that is obviously a square. Let us see. So, A bar is 10 Newton, B bar is 10 Newton, C bar is 10 Newton in the anti-clockwise order, and B makes 90 degrees with A and C makes 90 degrees with B, and the last side, obviously the fourth side is also making 90 degree with the A bar, and because the resultant is one of the sides of the square, then its magnitude is also 10 Newton. That means, in this situation, the resultant of three forces is equal to one force. And in the next example, more number. Let us take more number. If, first of all, find the number, actually, the angle here is 90. So, 360 by 90 is 4. So, the polygon sides are 4. Here also, if each angle is 30 degree, then the number of sides of the polygon n is equal to 360 by 30, which is equal to 12. So we have to consider a 12-sided polygon. We have to consider 12-sided polygon. And the 11 sides represent the 11 vectors. Then the last side represents the resultant in the opposite order, whose magnitude is equal to one of the vectors. So this is the way in which we use polygon law of addition for vectors of same magnitude.